So this question is about diffraction, and it's the how intensity varies with angle when electrons are diffracted by a nucleus. So really, this is checking a few things. So it's checking that you understand that when electrons are diffracted by a nucleus, so it's talking about a single nucleus. So do you understand that it's a single nucleus, and do you understand that it being blocked by a single nucleus will end up with it describing something that looks most like a single slit diffraction pattern? Okay, so once you demonstrated or understood that, you're then required to be able to identify which of these is a single slit diffraction pattern. So this is a light source. It could be a source of any wave through a single slit, and then you get this fairly typical pattern where you get a large, broad central maximum, and then you get lower intensity as you move away from the central peak, and this lower intensity, the central maximum, and then the next one is much lower intensity, and then the next one after that is lower intensity again and lower intensity again. So you get this decline in intensity. The only pattern which looks remotely like that is the first pattern. B has a uniform intensity across all angles, which wouldn't make sense because the central maximum is always brightest. C has the central maximum being bright, but it is not very broad relative to the spacing, the size of the actual maximum relative to the next minima. The next minimum isn't very big, and also all of the next maxima are at the same intensity, which isn't correct. And this one, all the maxima away from the central maximum are at the same intensity, and where they should be lower. So A is definitely the right answer. Of the rest, C is the closest, but C cannot be right because the second one from the central point should be lower, and this one should be lower again.